Good morning, participants. Can you all hear me?
Good morning. Yes, we can hear you.
Hope all are safe at home. I welcome you all for the FTP on machine learning using Python, organized by Department of Computer Science, Vistas. Credentials are: she obtained her PhD from Anna University, Chennai. Her research interest includes parallel and distributed computing, grid computing, cloud computing, big data analytics, and machine learning. She has worked in various colleges in and around Chennai, and she has published more than 30 research articles in reputed indexed journals. And she is a life member of ISDE, and she is acting as a reviewer in many reputed journals. And she had been a resource person for many FDP workshops and webinars in recent technologies. After the session is over, you can fill your feedback link in the chat box, and then you will receive your certificate within 3 days. Thank you for being here patiently in this session. Now I hand over the session to Dr. Doreen, ma'am.
Okay, thank you, ma'am.
Doreen.
Thank you, ma'am. Thank you, Jerry, for the invite. Can you all hear me? You can put on the chat session. You can put on the chat session, yes. Yes, thank you. Thank you. And there are a live streaming going on in YouTube. I hope you can also hear me. Okay. And still people are coming. Okay. Very good morning to one and all. Can we have our cameras on, please? Keep your mics on mute. You can have your cameras on. Thank you. Thank you for your response on hearing me. Now we are going to start off with the session. Yes. So throughout the session, I would like to have your cameras on and your mics off. Okay. A very good morning to one and all present here. You will be seeing on your mobile 2 Doreen Robin. Okay. In one Doreen Robin, you'll be able to see my video, what I'm speaking with you. The same visual will be shown to the YouTube live stream members. All right. That is the second session of stream that is going live within now. And one more session, you can see those who are into the Google Meet can see my screen. Okay, you will be able to see my screen. Whether you're able to see my screen, or you're able to see my screen? Yeah, thank you. Thank you for your response. Okay. So today we are into this topic on machine learning using Python. Okay, we are going to see about machine learning using Python. And I would like to thank the invite from Dr. Kalai Selvi ma'am, the HOD of Computer Science Department, Wales University. And I'm the founder director of Computational Intelligence Research Foundation. I had been into engineering colleges for a decade, teaching the faculty members. And then I started this research organization, and predominantly we work with big data analytics and data science using Python and deep learning technology. We also work with software testing, cyber forensics, and as most of your faculties, the technologies keep on increasing, right? What we learn is not what we teach, right? As faculties, we need to upgrade ourselves every semester to students. Then only we can stand in this field of education. So thank you all for joining. For today's session, we'll be seeing about NumPy, which is called as numerical Python, SkyPy, which is called scientific Python, and we'll see about Pandas, which stands for Python analysis. Okay, it's used for Python data analysis. Matplotlib, how do we are going to use plotting your maps? Okay, and then we'll be seeing about Seaborn, machine learning algorithms. How do we do a machine learning algorithm? So before we start off with machine learning algorithms, right? Can one of you answer what is machine learning? An example of a day-to-day life. What do you think it could be in machine learning?
Hello.
Yes, ma'am. You'll be seeing two Doreen Robbins. In one, you can see my video. On to the other, you can see my screen. Now I've shared the participants' video. Yes, can any one of you say what is machine learning? An example for machine learning. Yeah, Google Assistant. Yeah, thank you. Correct. Kokila ma'am. Oh, you want me to raise my Okay. Thank you, Regina ma'am. Yeah, thank you. Anyone? Yeah, any application. I want anyone can say any one of the application. Yeah, Amazon Echo, Gmail. Regina ma'am, can you put your mic on mute? Okay, sensors in AC. Thank you all for the response. Okay, so many things where we train a machine. For example, early days, like in hospitals, right? Correct. We use robots. Okay. So many things. Okay. So what I'm trying to say is, what we train a machine, and the machine does the job. For example, I thank for most of you have answered the questions, right? Most of you have answered the questions, okay? In using like hospitals, AI, different things, right? Even if you take a simple example of a washing machine, what we use in our home, right? What washing machine we use in our home is an example. A washing machine that we use in our home, we just load our clothes and it has already been programmed. Okay, the washing machine has already been programmed. Like if it is a cotton, then we give for higher speed, and if you what temperature we want, what speed of spin we want. Okay, it goes accordingly. So something where we train a machine. Okay, here there are plentiful algorithms available in machine learning. So before, when we were learning in our colleges time, we need to write our own algorithms. For example, if you're going to do an algorithm using a support vector machine, okay, or XGBoost or gradient descent, anything, okay. But now all the algorithms are being given in a package in Python. That package is called as Scikit, okay. That package is called as Scikit, where there are different things available. Like you can do a classification algorithm, you can do a clustering algorithm, you can do a regression algorithm. In today's session, we'll be going to see how we are going to present, okay, what are the steps that we need to take to write a perfect machine learning algorithm. And then we'll be seeing some of the examples, some of the Arulmozhi ma'am, kindly don't present your screen. I wish the participants not to present your screen because I'll be presenting my screen. All right. And so today we'll be seeing about it. And I hope most of you would have learned about machine learning also. Okay. To start off with, Python for data analysis. Panda stands for Python for data analysis. So first we are going to see the overview of Python libraries. Somebody's mic is on. Can you put the mic off, please? Sumitra ma'am, can you put your mic on mute, please? Yeah, thank you, ma'am. So if the mics are on, okay. You just click over the mute, please. Are you able to see my PPT now? Are you able to see? Okay. So we are going to see about the overview of Python libraries for data science, okay? And then we'll be seeing how to read the data for selecting, filtering, for data manipulation, how do you sort, group, and rearrange, okay? And most importantly, say for example, we are into engineering colleges or different colleges, okay? And we'll be, say for example, our colleges are 25 years old. Okay, so if you are going to have a file of all 25 years and could be able to, if you want to find in the data, we need to traverse through all the files to get certain data. Say, for example, if everything is visualized, then it will be easy for us to find maybe the past percentage for 25 years. If it is in a graph of a plot, it is very easy for us to see how the colleges was improving in the past percentage. Another thing, how many students are employed, okay, how many students are employed through the campus placement for the past 25 years. If we have a file, it's very difficult for us to go pages by pages. Rather, if you're going to have a plotting, the basic plotting that are available in Python are matplotlib. Okay, the even more advanced plotting is Seaborn and Bokeh. Okay, Bokeh. You can make a note of it. The 3 visualization tools, okay, that is available in Python and that which is predominantly used are matplotlib. Okay, first is matplotlib, and the second is Seaborn, Seaborn, and the third is Bokeh. Okay, Bokeh. And for everything, we have got different types of analytics: descriptive analytics and inference analytics. So, what are the Python libraries? Okay, I say we'll be seeing about NumPy, SciPy, Pandas, and scikit-learn. And visualization, we'll be seeing about matplotlib, Seaborn, and Bokeh. Okay, what is NumPy? Okay, I said NumPy stands for numerical Python. NumPy stands for numerical Python, where you could be able to use for multi-dimensional array and matrices. Okay, say for example, if I'm going to take an image, I can convert the image into my NumPy array. And if I want to take a counter of the image, or if I want to do manipulation, many things can be done using NumPy. And most of the scientific applications are done using NumPy. So it provides vectorization of mathematical operations on arrays, which improves the performance of any algorithm. Okay, and many other applications are built on NumPy. That is, we'll be using about your numerical Python. And the second is scientific Python. So it has got a collection of algorithms. Okay, it has got a collection of algorithms where you can do your differentiation, integration, optimization, statistics, linear algebra. Everything can be done using your SciPy. SciPy stands for scientific Python, and it is built on NumPy. Okay, the most used package in Python for machine learning. Before we start, right, we need to do an analysis. Without doing analysis of any data set, we will not be able to start proceeding. Okay, say for example, if you're going to handle for a set of students for the first time, Okay, when we go into the class for the first time, maybe it's a first year students, we will not know anything about the students. Okay, but we'll be just trying to understand, analyze the students. So as teachers, okay, as faculties, we always use the skill of asking questions, okay, when we take a class. So even when we started this session, I asked, can you give any examples of machine learning, any applications of machine learning, and many of you have answered it. Okay, and likewise, when we go and start with the class, we just use the skill of probing question. Some questions we ask the students, right? We ask the students to try. Why do we ask students? To try to understand what level they are in. Okay, and after we take certain class, then we keep them a test. Okay, at the end of the test, we'll be able to know at least to 30% how each student are. By the end of the semester, we entirely know the quality of every student. We know about their attitude, we know how it's their studying skill and everything, right? So we need to do an analysis before we need to proceed using any of the machine learning algorithm. So analysis is very important. Say, for example, you go to any hospital. In that hospital, if they are going to have a plentiful number of doctors, say for example, for cardiology department, for heart department, they've got 20 doctors, and you're going to the hospital for the very first time, and you're going to the hospital for the very first time, and there are 20 doctors, but that hospital is giving you a choice. Okay, you could choose any one among the 20 doctors for your treatment. Okay, how will we take? We will not know anything. Supposingly, if you go to the hospital and there is a big plot of analysis, so for each doctor, like in many departments are there, I'm just taking an example of cardiologist. So doctor one, so many patients he has treated, so many have survived, so many have died. If that visualization is given for you about the doctor for maybe for 10 to 15 years, so we will have an idea which doctor treatment had a most successful rate. Then it is easy for us to choose that specific doctor for our treatment. I repeat the situation again. You go to an hospital, okay, go to an hospital for any heart problem. Okay, that hospital has a separate department of cardiologists, okay, and there are 20 cardiologists in that hospital. That hospital is giving you a choice of choosing your own doctor for your treatment, one among the 20. Without know anything of the doctor, we cannot go and just figure out, because we are going to deal with life. Supposing if there is a big visualization graph about all 20 doctors, okay, how many people he has treated, how many people have succeeded, how many, what was their death. If that is given, we will know the survival rate of the treatment by the doctor for n number of patients, from which it is very easy for us to figure out. We just choose which is the best, right? Which doctor has got the most successful rate, then we'll be able to choose that specific doctor. So analysis of data is very important before we start with the machine learning. So what is analysis? That's an example we have given. Here in Python, we have worked at CIRF, we have worked even with 10 lakhs and 20 lakhs of data. And we have got results of for the machine learning algorithm, for deep learning, and every algorithms that which uses Python with less than a second. Okay, so that is the power of Python. So I strongly advise everybody to start working with Python. If we have a hands-on training of how to work in Python, it's very easy when we go before a student. Okay, when we just, it's not only speaking, I will show you the demos of it. Okay, how we have worked, and it adds a data structures called as data frames. Okay, here the data structure that is used inside your pandas is called as data frames, and here you can do reshaping, merging, sorting, slicing, whatever you want to do. Because if you're going to say, for example, your machine learning algorithm also plays a vital role in climate prediction. Okay, climate prediction. So today it is going to hot. Today, the hot season has started from today to May 28. Okay, so it is how it has been predicted. So from the satellite, the data scientist will take large number of data, and they will know what are the particular values are needed. Only those particular values are taken, and a prediction is done, and from which they are able to tell us today what should be a temperature. Okay, what would be a temperature, what is the humidity, what is the precipitation. Okay, it is not only for today, they give us the climate and weather statistics for the next 7 days. How do they do the seven statistics? They take large amount of data from the satellite, and they are not going to use all the data. Okay, they are not going to use all the data. They go figure out, and only the necessary data they will be taking it and manipulating it and running their own algorithm and predict. So tomorrow, because of these parameters in the previous year, if these parameters were like this, then the temperature was like that. So with an existing data, they compare with the present data and they predict. I repeat, they take the present data, compare its value with the existing, that is the previous data, then they manipulate it what will be your future temperature, your climate or wind speed, whatever it is. So data analysis is much needed before we start writing our machine learning algorithm. And one specific point that is very much needed is that it does not, we need to know how to work with missing data. Okay, say for example, if you're going to take data from the satellite, you may not have values for everything. There will be missing data. So if a missing data is an essential data, then we need to manipulate it, okay, or we need to remove the entire row, because prediction, we will not, when we do a prediction with the missing data, our accuracy of an algorithm will go drastically low. Okay, accuracy of an algorithm will go drastically low. And next we are going to see about scikit-learn. Okay, here is the space where the Python is giving all machine learning algorithms like classification, regression, clustering, model validation, pre-processing. Okay, first we see of classification, clustering, regression, model validation, and pre-processing. So before we start, and this is built on top of NumPy, SciPy, and Matplotlib. So whenever we start learning our machine learning algorithm, we should start working with, NumPy. We should know to work with SciPy, the Panda, Scikit-learn, Matplotlib. So though we have done all these analysis and all the machine learning work, but we should know how to plot it. Okay, plotting will show how efficient is an algorithm. Okay, how efficient, what is the type of data is. And Seaborn is based on Matplotlib, and this plotting in Seaborn is more beautiful, is more better than
Anand has spent many of his days going on fishing trips in his uncle's boat. So suppose when you go to...
Can you all see my screen? Dr. Madhubala is presenting. Screen sharing. Hello? So,
Yes.
yeah, can you see the screen now? For you,
No, madam.
yeah, got your screen. I'm getting message. You'll be seeing 2 Doreen Robbins. But for the streaming viewers in YouTube, you'll be just able to see my video and not my PPT. All right? Okay? You will just go and click 2 Doreen Robbins. Those are in the Google Meet. There will be 2 Doreen Robbins, and one you'll be able to see my screen, my video, and other you can be able to see my screen. So these are the tools that is more important for us to start with the machine learning. Now I'll show you, okay. So any questions till now? We have seen about NumPy, Matplot, SkyPy, Scikit-learn, Matplotlib, and Seaborn. Okay. Now can you see my screen? I've just, can you see? I've just taken my NumPy and Pandas. Okay, somebody's mic is on. Can you put your mic on mute? Others, kindly don't present your screen. Balu. Okay. Now I'm able to mute it. Okay. So here I've taken a data of a country. Okay, where there are different sections of a country, and this is where they are doing their marketing. Okay, SEO is for search engine optimization. Some of them are using their work in AdWords, and some of them are using in Reddit. Okay, so here this is the first when I use. I'm just doing the analysis. I'm reading my CSV data. So it has got 1,794 rows and 6 columns. Okay, a file that contains so many rows and so many columns. And if I give a function called describe of, it will take the content of it and it will describe taking only the numerical values. Okay, to take only the numerical values. Since there was no header, I'm just trying to give an header for this. So my date time, what is the event, from which country, what's the user ID, through what source they're able to do it, and what's the topic. Okay, about North America, Africa, Europe. Okay, this is a data set of 1,795 rows and 6 columns. And I'm just want to do a visualization. I'm just taking 50 samples. Okay, whatever I want to slice it. There are 6 files. Okay, there are 6 columns, out of which I'm just going to take only if it is country is 2, and I'm only for the country 2. There are different countries from 1 to 7, and from the only country that is 2, I'm going to take the user ID, topic, and the country. If I give head, it takes only the first 5 rows. Okay, it takes only the first 5 rows. And now we'll be seeing how deep. This is a very simple example we have seen. Okay, I'll show you how deep we can do an analysis, only analysis using Python. Okay, only analysis using Python. So I'm going to take the data set of wine. Okay, wine data set. So different wines, okay, of different countries, how the sale has been. Okay, I'm using the Pandas, NumPy, Matplotlib, Seaborn, WordCloud, and I said if there is a missing number, it is very difficult for us to work with our data sets. So, and Squarify. So these are the packages we can take for data analysis: Pandas, NumPy, Matplotlib, Seaborn, WordCloud, and missing numbers. Okay, and Squarify is used if I'm going to have a huge volume of data. I cannot have just bar graph of x-axis and y-axis which keeps stretching, and then I will not be able to get it out. I will show you how it has been done using Squarify. Okay. So I'm first taking 150K, okay, that amount of data. So 1,50,000, okay, 1,50,000 data. I'm going to take about a wine, okay, wine review. of 1,50,000 data, 50,000 plus data, and it has got 11 columns. And the next data set, okay, next data set is also about the same wine review. It has got 1,29,000. So 1,50,000 plus and 1,20,000 plus. Okay, I'm going to take and I'm going to concatenate it. So which makes about 2,80,901. Okay, 901 data. So I am taking two data set and collecting both data sets. So this first example when I showed you, it was only having 1,794 okay data sets. But in the second data set I'm going to take, which is going to have 2,80,000 data sets. So here always will take me 5. So these are my data. From which country is that wine from? What is the description about the wine? What is the designation? So how people are voted for the wine, and what is the price of the wine, from which province? So it is from California or from northern Spain or Oregon, or which province, and in that province from which region, okay, and in that province which region has also been taken, and then the taster. And can you see somewhere it is NAN, which stands for not a number. So here this data set has got lot of missing values. So as said earlier, if there is lot of missing values, it will be difficult for us to start working with the machine learning algorithm. The first step before we start with the machine learning is a data analysis. Okay. So we have got 14 columns, and whenever we give describe of, we'll take only the integer value, and it will take the count of it. Okay, and then it will take the top values, the frequency, the mean, standard deviation, minimum, top 25. Okay, now can you see with 2 lakhs of data, I'm just plotting a graph of wine and its color. Okay, I'm just plotting a MSN, which is a missing. How many missing numbers are there in all these columns? Okay, how many missing? So easy for me to visualize. So I know my total value is 2,80,901. When I see this graph, I can easily figure out. See here, this winery has got 2,80,901, and the first ID has got 2 lakhs, and here the description has got 2,80,901. And if I see the country, there is some missing values. So I said before we start with the machine learning, we need to analyze. It's very difficult for me to check all the 2 lakhs data for all the 14 columns whether there is a missing number. So using this package, it is done. So here I'm just plotting another graph, and which are the top distribution of wine reviews from top 20 countries. So US has given the more reviews, and France, then Italy, the Spain, okay, Portugal. So from collection from this data is very difficult for me to analyze it, but when I go down, it's easy for me to. When I have a visualization of graph, it is easy to analyze it. This for this application, I have used Seaborn. Okay, the distribution of prices for both this plot and another box plot, and this how the country wise how the price is increasing. So when I see here, I can see Switzerland has got the highest price for wine. And this is what is a squarify. Okay, I'm just going to see the price of it. I'm going to cluster the data into a square. So which means in Switzerland, I can see what is the price, and from here, from England. So most of when you're going to work with 10 lakhs or 20 lakhs of data, we go for Squarify. And the most expensive wine is from France, and the least expensive wine is from Portugal. So it's easy for us to see from the data sets. Okay, so this is called about the visualization of data, which is more rated, and most rated wine and country is France, and least rated is Uruguay. Okay, Uruguay. And here the country wise box plots. Okay, I'm just in each, as we saw in the data set, each of them have given different points, and we'll be able to see it. Okay, we have used a joint plot. And the grapes, what are the materials of grapes? So from 2 lakhs of data, and from which is the most grapes least rated, most rated. Okay, and here I'm just saying the points. Okay, what points have they given for each prime? So it, as seen before, it is France has got the largest point, and most expensive wine, most expensive wine prepared in the winery, and so much and so more we can able to do using our data analysis from this 2 lakhs of data. This is the word cloud. So from the reviews given, what are the description? So some of them have given black cherry. Okay, and lot more can be done. So this is a simple example of wine analysis. Okay. So this is how we have seen. Okay, this is how we have seen about our data analysis. How we take a data and different plots of graphs can be made. Okay, and now I'll show you yet another example. Okay, in India, we have taken a data set from India for the past 10 years. Okay, for the past 10 years, how rainfall has been taken. If I'm going to give you an Excel file of all 10 years from different countries, okay, from different countries, how they are going to see it is it's difficult for us to find which country has got the most which country has got the most rainfall in which month or which is data. Now I'll show you the work that we have done. Okay, I've taken the rainfall distribution from 2004 to 2010. Okay, 2004 to 2010. And here we have used a package. Is somebody's mic is on? Okay. So from this historical rainfall, so we have taken for a few places in India. Okay, so the data set is taken in the form of JSON, where it stands for JavaScript object notation. Okay, I'm just taking. Maybe we can take Chennai. This is Chennai, okay? In Chennai from 2004 to 2010, from January to December, how was the rainfall? How was the rainfall? So you can find in 2005, okay, in 2005, September, we have got the highest rainfall. Is it possible for us with all collection of data, either in Excel or whatever, find, okay? It is difficult for us to find. But with visualization, we can easily grab. Not only for, we have also taken for Jammu Kashmir. Okay, so we can find in 2010, they've got the highest rainfall in the month of July. Okay, so easy. So data analysis is more important. Okay, this is from another country. So we can see in 2007, July, this country has got, this state has got the highest rainfall. So for these works, we use data analysis to be done before we start with our work. Okay. Now I'm going to show you about machine learning algorithms. Okay, machine learning algorithms. So I'm going to take a data set of a product which is won and which is lost. Okay, a product which is won and which is lost. I'm going to take a sales data. So from the sales data, I'm going to do a prediction. Okay, I'm going to do a prediction. This product has got a sales, and also it has got the sale. This product has got won or lost, and from which I'm going to predict in the future which product has got the most sale. Okay, which product has got the most sale will be able. So I'll be increasing the production of the product which has got the most sale, and I'll be reducing the production of the product which has brought me the heavy loss. Okay, for this is an example of machine learning algorithm. So here I'm going to take an algorithm. I'm going to take the data set. First step, I'll be doing a data analysis of the data, and then I'm going to work with 3 algorithms. Okay, from which there are many metrics available, performance metrics, and that we'll see together. Okay, so this data set has got 78,000 rows and 19 columns, 78,000 and 25 rows and 19 columns. So as I'm using here, you can see it's a car manufacturing company. So external accessories, car accessories, which region? Okay, northwest. So there are different route to markets. They go to a reseller and they sell the product, or from the field they sell the product, or whatever it is. And how was the elapsed days in sales stage? And this is what I'm most thinking about. And this data set has got an opportunity result, whether this product has won the sale or it has lost the sale. Okay, and then we are going to see about different parameters. Okay, And whenever I use head, it takes only the first 5 values of my data set. So I'm taking a data set of 78,025 rows and several columns. And when I use tail, it takes me only my last 5 rows and all the columns. So these are the data types. Okay, if I use a describe, it takes the integer values and then it will do my count, mean, standard deviation. Mainly count I'm doing here is to find whether there is any missing data. So my data set is called 78,025 rows. Okay, and here I can see 78,025 is available in all the description of count, which means this particular data set has no missing numbers. This particular data set has no missing numbers, and then I'm finding it out. So just with my route to market, so through which route this product has been, either through field sales or reseller or any other methods, or if I do a telesale, that how do I do an advertisement, and then whether through that has it reached the market, or using tele coverage. So I'm using 2 colors, okay, and a yellow blue color which says the product has won, okay, and this says it is lost. So I can see the heavy loss for my products, okay, the heavy loss for my products is only through the field sales, and the good the sales of my product is through my reseller. So I have to channelize my path for which route is better to increase my product, okay. And then this is another while and plot, and I'm just doing my pre-processing before I send it, and I have to convert all my categorical data into my numerical data. So I convert my categorical data into numerical data, and I have to split my data into data and target. My target is what? Whether my sales is won or it is lost. Okay, and I'm going to split my data into my data and target. Okay, once I split my data into data and target, and then I'll be training my machine learning algorithm using my training data set. Okay, once I finish, so if these values are like that, then the sales is won. If these values were like this, then the sales is lost. My target is my sale, whether it is won or lost. Okay, and my data set is a collection of data through different parameters we have seen. Okay, and then I'm splitting it up, and then I'm training my algorithm. The first algorithm we can use is called as Gaussian naive-Bayes algorithm. From scikit-learn, I'm just importing the Gaussian naive-Bayes, and also there are different metrics. There is n number of metrics. There are certain metrics which is much needed to validate our machine learning algorithm. So first, I'm taking an accuracy score, how accurate it is, and I tell to all faculties it is impossible for us to get 100% accuracy. Okay, it is not possible, but we can achieve up to 95% accuracy. So how we train, some data sets will fit for some algorithm, some data sets will fit for another algorithm. So to do a perfect research, because many research algorithms have been compared, so we always take a set of data sets and a set of algorithm. We try to trial it on all different algorithms, and at the end we'll be able to figure it out which algorithm is best for this data set. And also, as professors, when you start writing it, we should find the flow of it. Okay, how it is important for us to take a data set and put it on the algorithm and validate it. Okay, so here for this algorithm for naive-Bayes, I'm getting 75%. Okay, the next algorithm I'm going to try is called as support vector machine. For that, I'm getting 46, which means my accuracy is tremendously less. So this algorithm is not good for me to test my sales one. But comparing my support vector machine with my Gaussian naive-Bayes is better. And next, I'm going to try with my k-neighbor classifier algorithm. It has given me 81%. It gives me 81%, which is the best. So now I am able to compare with my naive-Bayes, with my SVC, and k-neighbor classification. I can tell that this algorithm, k-neighbor classifier, is best for this data set in comparison with other algorithms. There are n number of algorithms available. We can try it out. And from Yellow Brick, I'm just using a classification report. Okay, precision, recall, F1, or how much it is true positive. And after the end of the algorithm, I'm getting true positive. It is truly positive, but my algorithm is getting false negative. So positives and positives will be checking it out, and then through which I'll be able to tell my accuracy of my product. So you have my data set. And after I get my prediction algorithm, okay, I'll be comparing the output with my original, and from which I will be able to find the accuracy of an algorithm. Already I have a results. Okay, this is a supervised learning, which means I have the results of the data set. But when I give the data set into my prediction, like either it is Gaussian Bayes or linear SVCE or K-neighbor, I will only give the data. From the data, it will tell me the target whether this product is sales or what. So I have my predicted data. I have my original data. I compare my original data with my predicted data, and then I'll be finding my accuracy. In which, in this example, it showed that K-neighbor classifier was the best, and these are the other metrics: precision, recall, F1 scores. Okay, and there is another confusion matrix, the ROC, the receiver operator characteristics, area under curve. So that there is a way we have our ROC curve and precision recall curve. So these are a few metrics which enables me to tell about the algorithm, which enables me to tell about how good is our algorithm. Okay, there are different um, I can use a classification. We can use a k-means algorithm. Okay, we can use a k-means algorithm. We have to give how many number of clusters we need. Say, for example, if you're going to take the academic performance of students, as we are faculty, we know we can cluster students into top students, average students, and below learners. So if you give 3 clusters, if you give our data from your starting of the semester to the end of the semester, your machine learning algorithm will tell with the marks, okay, whether this cluster is changed from the starting to the end. Okay, to be a perfect teacher, the below average student should propagate to the middle and to the above by the end of the semester. So those can be done. Here I'm just going to take about some students, and we have done a k-means algorithm and clustering the data. So okay, we can do the clustering of data using k-means. And here we can see, using the confusion matrix, we'll be able to see how far the students have been clustered into. Okay, there are even more many algorithms, but as we have got very less time, and we are able to show this, and I will show you. I want you all to we can do lot of analytics. Okay, we can do lot of analytics. Wherein it shows how see, I use my company's website, which is called www.cirf.co.in. Okay. Now I have trained my algorithm. Okay. I am so wherein when any people they see my website. Okay. When any people they see my website, I don't know from where you are all, but still I can show you an example now. Okay. I'll show you an example now. So this is an example of a Google which has done a machine learning of a. So I will not be able to go to my website every time to check how many people are there, how many people are viewing my website, how many people are viewing my website, how it is done. Okay, how it is done. And now I'm going to show you from my company's website. And after some time, after 2-3 minutes, okay, I'll tell you to log into my company's website, and I will show you how the analytics is with that. I don't know now from where you are, where are you viewing this webinar, but I can tell you. By the time it is getting set up, is there any questions? So we started with machine learning. The basics to learn with machine learning is NumPy, SciPy, scikit-learn, Matplotlib, Seaborn. And then we have seen how it has been done. And then we have seen a couple of exploratory data analyses of a normal simple application. And then we saw about the rainfall in different countries, okay, for the past 10 years. And then we have seen about a data set of sales and one. And we have how it has been splitting up the data into data and target. Okay, how it has been split up into data and target. And then which algorithm was the best. Okay, which algorithm was the best. So now, if I could see my audience, okay. So this is my company's website. I can see one active user who's there in the. I wish all the participants to move on opening up. Okay, www.cirf.co.in. I've kept my screen present screen. Okay, I've kept my screen as my present screen. As you log in into my company's website, I can show you from my screen. Okay, how it is increasing. Now it is increased to 2, and one person is viewing from desktop and other is from mobile. Can we quickly have my company's website is www.cirf.co.in. I'm not doing anything. Okay, I'm not doing anything. I've just trained my algorithm in such a way so I can see from which places people are seeing. Okay, from which places. And even YouTube viewers also, those who are viewing using YouTube also, you can log into my website www.cirf.co.in. Now, YouTube viewers, most of you are asking, PPT is not been there because it's a live streaming. So happy to see like 243 people there on YouTube live stream. Actually, we're trying using another application. Okay, at the start we were not able to publish using the streaming. Okay, that is what we have shifted over to YouTube live streaming. Just before we start the session, we have set it up. Sorry for the inconvenience. Okay, but the particular software was working till yesterday, but today we had some issues. So I'll put the website for the YouTube viewers in the chat session. Yes, for certificates and feedback, one feedback will be sent by Kalai Selvi ma'am, the HOD of Computer Science, and I will also share one of my feedback form. Okay. So now I can see there are 61 viewers, and some of them into training, some of them, two of them, most of them, 54 of them are into the home page. Okay, 57. Okay, it keeps increasing. I think Google Meet viewers can view in my page. Okay, Google Meet viewers can view in my page. So it keeps increasing. Like I got 73 viewers, and most of them are into desktop. 84% are into desktop, and 16% are into a mobile. artificial intelligence, Razer, data science, and research in education technology. From the start of this lockdown till now, by the grace of God, we were able to train 400 faculties around the globe. 400 faculties around the globe. It's fully a hands-on session, how to enable teachers to take classes live using online with face-to-face interaction and screen sharing, and many tools we have taught. Like by the grace of God, we have trained 400 faculties during this lockdown. Okay, and a lot of tools we work for education technology people, and we train and make students and faculties. We give internship for students, we give internship for faculties. As a faculties, we need to get ourselves equipped before we go into each semester. We work with funded projects. We work with big data analytics, Python programming, hybrid mobile application, front-end web development. And like students, they come every semester and they learn with us. And faculties. And we also help research scholars. We train them, but it is in the hands of research scholars to develop their projects. Okay, they develop their projects. Here, we don't develop projects and give. Okay, here we don't develop projects and give. They come with a problem statement. Okay, they'll come with a problem statement wherein we will be able to train them. Taking their content, we'll be able to train them. Okay, and they develop their projects. For sure, we are not developing projects for them. We will train them and they develop, and we have got a couple of researchers that is going on, and we work for companies also. Company project is also being done. All right, and this is my company's website and my mail ID and my mobile number. You can make a note of it. For YouTube viewers, I will just put it on your chat session now. For YouTube viewers, I'll put on in the chat session. For any doubts further, you can call to my mobile number, okay, which is 900-30-21355. Okay, and then my mail ID is Doreen, cirf@gmail.com. Okay, and my company's website is www.cirf.co.in. Okay, and I have a good news to share with you. In my company's website, if you go to the home page, okay, we train people to do hands-on. It's not like what we speak. We will be having a face-to-face interaction, and at the same time the participants will be developing their own projects. So from May 11th to 15th, we have this course called online hands-on course on machine learning using Python. Okay, so here each of you will be working on set of applications. Like first day we'll be seeing about NumPy, SciPy. The second day we'll be seeing about Matplotlib, Pandas. The third day, the different classification algorithm and how do we evaluate an algorithm. Fourth day, we'll be seeing about clustering and the different algorithms and performance visualization with data visualization and regression. At the end of this course, all the participants, okay, either the students or faculty or whosoever, they'll do a project on their own and they will be presenting it. Okay, and if you register it before May 6th, the course fee is 2,000, and after May 6th, it is 2,500. So if you are interested, you can come to this website, to my company's website. There is a form called registration form for machine learning course. And also this is the third batch we are starting for digital classroom. So where we teach how to set up a Google Classroom, the Jamboard, the slides, the forms, the sheets, and video lectures, and Google Meet. Most of you would have attended it because I could see some of the names. Okay, that is also between May 11 to 15. This session happens in the afternoon, 2 to 4. 2 hours is a session, so Monday to Friday. And the course fee is 1,500. And machine learning course is May 11 to May 15 from 10 a.m. to 11:30. Both are hands-on session with face-to-face interaction. And you will share your screen and I will also share my screen with you. Okay, and I will share, Kalai Selvi ma'am will share a feedback link, and I will have my own feedback link. I will share it with, I'll get your emails from Kalai Selvi ma'am and share my email IDs and share my feedback forms with you. Now over to Kalai Selvi ma'am. Yes, ma'am. Regina ma'am, there's a question. The accuracy will change. The accuracy will change depending upon the data sets. Okay, the accuracy will change depending. So to write a good algorithm, you should at least have 3 data sets to verify with your algorithm. Don't ever conclude with one data set with algorithm. that may not be right. That may not be right. Any other questions? Yes, you can unmute and ask. Thank you.
Thank you, ma'am.
Thank you.
This is Dr. R. Parameshwari, Associate Professor in the Department of Computer Science, Boosters. Good afternoon to all. It's my privilege to propose a vote of thanks on this occasion. I, on behalf of the Department of Computer Science and faculties, extend a very hearty thanks to the Honorable Speaker, Dr. Doreen Robin, Founder and Director, CARF, her presence, and took out valuable time even in the busy schedule. I must mention our deep sense of appreciation for Dr. Doreen Robin for their presentation. Also, I would like to extend a special thanks to Dr. Khalid, Professor and Head, for inspiring us. I wish to express my gratitude to our management for providing a constant encouragement and support. No program can become as successful with a single person. So I extend my thanks to our Department of Computer Science faculties for their support. Thank you, participants, for making this event successful. I hope all of you fill the feedback form, so it will be useful for us to send a certificate. Thank you. Thank you so much.
Any questions you have, you can ask.
Do we have a concept for unbalanced data sets in machine learning?
Yeah, we have. We have different algorithms for balanced data and imbalanced data. If you have an imbalanced data, there is a different algorithm how to work with the data sets.
Okay, so are there any specific functions for balancing or any specific libraries in Python for balancing the data set?
Yes, it is there. I am balanced.
I am balanced. Okay, thank you.
Okay.
Ma'am, where can we get the feedback forms, ma'am?
They'll send it to your mail.
Okay, ma'am. Thank you, ma'am.
There's no other question? Thank you all for joining the session. You're winding it up. Thank you. God bless. Sure, Jonisha ma'am, I'd be able to conduct webinar for your students also. You can contact me through my website or through my mail ID or through my mobile number. Thank you all for joining to the live streaming also. What's the difference between? Yeah, artificial neural network, it trains different layers. Mebin sir, the artificial neural networks trains different layers before an algorithm has been done.
Hello.
Is there any other question for the screen viewers? You can post it in the chat session. I'll be able to answer it to you. Welcome all. Welcome all. Yeah, we can implement NN algorithms, neural network algorithms in Python. There are plentiful algorithms available. Sure, Satya Madan sir, you can contact me. Thank you, Jayashree ma'am. It's a pleasure to seeing you again. I'm extremely sorry for the YouTube viewers. The following session, I'll have the screen share in it. It was all done. Yeah, for YouTube link viewers also, you could send a mail to me. We will share the feedback to you. Thank you, sir. Muthu Ganesh, sir. Yeah, lot of applications you can do, ma'am. I don't know, Badi, Alikya. There are a lot of work even we do in biomedical process. Okay, image processing, there are plentiful algorithms. Okay, in image processing, you should specify what is your functionality. Accordingly, I can tell you what algorithm you can use. Yeah, the Shamla Devi ma'am, the data set could be of different sizes. It should be of different sizes. Like generally, I'll say if it is like 50,000, 5 lakhs and 10 lakhs of data, then only you'll be able to find the fault tolerance of it. I basically didn't use most of the PPT. I was just showing the running of the programs. Only the 5 slides I showed about NumPy, SkyPy, Matplotlib, SkyKit, and CBOM. And others are all I showed in the running of it. Okay. Thank you, Purna ma'am. Thank you. You can all send a mail to me. Yeah. YouTube viewers, we were not able to share the screen. We had some technical problem. The further session, definitely I will share the screen with you. Sure. Thank you, ma'am. Yeah, we can use Keras and TensorFlow also in image processing. What we do in machine learning also can be done in deep learning too. Thank you, sir. So, thank you all. So, thank you. Yeah, optimization can be done in machine learning algorithm. Hypertuning of parameters. Hypertuning parameters can be done, which optimizes your algorithm. Hyperparameter tuning is the concept that we use in Python for optimization. Thank you all. Bye.
Exactly.